This video is kind of going to summarize everything we've looked at over the last couple of weeks. So we started with slope. Remember, we have a slope formula, and we always represent slope with m equals, and my formula is y2 minus y1 over x2 minus x1. So that's how we find slope if I'm given 2 points. Okay, you can also think of slope as rise over run. And that's talking about your up and down over your left and right. So you kind of use that whenever you're looking at a graph. A couple of things to remember. Vertical lines have a slope that we call undefined. Okay, if you're looking at it, it's just a vertical line, so you know it's undefined. If you're doing it algebraically, you're going to have something on top divided by 0, which you cannot do. So if it was x divided by 0, can't happen. It's got to be undefined. Horizontal lines, right, they're flat. Okay, I cannot walk up a wall, but I can walk on a flat surface. So that's when your slope is 0. Okay, your horizontal lines like that. And then if you do it algebraically, you're going to get a 0 on top with something on the bottom, and that's okay. We just cannot divide by 0 ever, ever, ever. So we have an undefined slope. Then we looked at writing equations. Okay, sometimes you're given the slope in a point, right, or the slope in the y-intercept, or 2 points, and you just kind of put them together. We have 3 different types of equations that we talked about. One, we talked about slope-intercept form. Alright, that's y equals mx plus b. Okay, we call it that because I'm given the slope. And then b is my y-intercept. Okay, if you're writing an equation in slope-intercept form, one option you have is to find your slope and then plug in x and y to solve for b. Right, that's if you're given either 2 points or a point in the slope. The next one we looked at was point slope. Point slope is y minus y1 equals m, your slope, times x minus x1. Okay, it's called this because your slope is m. We're given the slope, and we're given a point, right? And that point is x1, y1. Okay, point slope is pretty simple. All we do is plug everything in. Keep in mind, it's minus. So if I plug in a negative, it's going to change to a positive. But we don't simplify, we just plug in our point and our slope. Okay, it's easy to write the equation because all you need is a point and the slope. But it's also easy to go from point slope to slope-intercept form just by multiplying everything through and adding whatever's over here with the y, or subtracting. You want to get y by itself. So if you have to write the equation slope-intercept form, you can always start with point slope and simplify it out to slope-intercept form. And the last one we looked at was standard form. Standard form is ax plus by equals c. Okay, so we got x and y on the same side and our constants on the other side. And it's got 2 restrictions. There can't be any fractions anywhere. No fractions, no ugly fractions. Okay, and the other restriction is that a must be positive. Now remember, a is the coefficient of x. So you got to make sure that x comes first, and it's got to be positive and no fractions. There are several ways to get rid of fractions, and there are several ways to get rid of negatives. So it just depends on the equation you're looking at. Then we graphed lines. So if we graph in slope-intercept form, right? So if we have y equals 2x minus 4, I'm going on my graph to my y-intercept of negative 4 and putting a point. Okay, once I have a point, I'm going to use my slope of 2 to go up 2 over 1. Up 2 over 1, and so on to get my line. If I'm in point slope form, so when I'm given the point and a slope, so for example, y minus 2 equals negative 1/2 times x plus 1. I'm going to use the point. So the point that I'm given, okay, my x comes first, it's opposite sign, so that's negative 1, and then my y is positive 2. So I'm going to go on my graph to that point, negative 1, positive 2. And then I'm going to use my slope from that point. So my slope is -1/2. That means I go down 1, right 2. And I can do that as many times as I need. And there's my crooked line. And then if it's in standard form, that's where we're going to use our intercepts. Okay, so standard form, I might have, let's see, 3x plus 6y equals 12. So first I might start by covering up my x. So if I cover up x, I get 6y equals 12. So y must be 2. It's my y-intercept. Cover up the y. 3x equals 12. So then x must be 4. That's my x-intercept. So I'm going to go on my graph to +2 on my y-axis. Stop doing that. And +4 on my x-axis. And draw a nice crooked line through those 2 points. Then we looked at inequalities, very similar to your equations, but now we either have a greater than, less than, greater than or equal to, or less than or equal to sign. Okay, a couple things to remember. If it's just greater than or less than, we're going to have a dotted line. If it is or equal to, we're going to have a solid line because we're including that line in our solution. If it's dotted, we're not including it. We're showing the boundary, but it's not part of our solution. Okay? Once you simplify your equation or whatever you want to do to look at it in point, slope, slope-intercept, or standard form, to decide which side to shade on, you plug in a point. Any point will work. Okay? If it's true, you shade on that side with the point. So wherever that side, that point is in relation to your line, you're going to shade on the same side. If you plug in that point and it's false, if it's not a true statement, you're going to shade on the opposite side because that means that that point is not part of your solution, so everything on that same side is not your solution. Okay, the easiest point to plug in is 0, 0, just because anything times 0 is 0. Sometimes your line goes through 0, 0, so you're going to have to pick something different. You don't want to pick something that's on your line. Okay, so then you just shade based on where you're at. Alright? Parallel versus perpendicular. Okay, so remember, parallel lines, they're never going to touch. Perpendicular lines, they're going to intersect, and they're going to make that right angle. Parallel lines have the same slope. Same slope. And perpendicular lines, their slopes are opposite reciprocals. Alright? So if I have an equation that is y equals 1/3 x minus 5. The slope of a parallel line would also be 1/3, same slope. If I have that same equation, 1/3 x minus 5, and I want a perpendicular line, that means my slope is going to be negative because it was positive, so opposite sign, and the reciprocal, so 1/3 becomes 3/1, or just -3. And that's pretty much what we've covered since the very beginning. We have a couple other things we've done since this, parallel and perpendicular, but we haven't seen this stuff in quite